Okay, let's go ahead and get started. Welcome to the North Central U.S. Climate and Drought Outlook for December. My name is Doug Cluck. I work for NOAA, National Oceanic and Atmospheric Administration, and my sub-office, if you will, is the National Centers for Environmental Information. I'm based out of Kansas City, but our main speaker today is going to be Justin Gleason from the state climatologist for Iowa. Luckily, nothing's happened in the climate over the last few days and weeks, so he won't have much to say. Or I'm completely wrong, and there's quite a bit to say. So actually, there's probably too much, so we're going to try to hurry through this as best we can and provide as much as we can. When he's done, we hope to have some time for some Q&A. So if you have any questions sort of live that we can sort of answer on the fly, Dennis Toddy from the USDA Climate Hub and I will answer those, and any that we can't, we'll get to at the end. And stay tuned for that if you want to be a part of that session. Anyway, I'll turn it over to you, Justin. You got a lot to talk about. Thank you.
All right, sounds good. Thank you, Doug. Good day, everyone. I'm pleased to be here with you all. As Doug mentioned, Justin Gleason, state climatologist of Iowa at the Iowa Department of Agriculture and Land Stewardship here in Des Moines, Iowa. We've had an interesting 24 to 48 hours across the state and an interesting month across the region. So let's get to it because we do have a lot to talk about. Now, the reason why these webinars are so successful and beneficial, I believe, across the region is because of the collaboration that we have with our state and federal partners, but also our regional climate hubs, USDA Climate Hub up in Ames. We all have a great collegial working relationship. And given how extremely insane the weather has been over the month of December, I'm indebted to my colleagues for getting me this information and for helping me along on this. So the next regional webinar will be in January. I didn't put the date there, but it will be Dr. Jeff Andreessen, the state climatologist of Michigan. And then below here are links to the past webinars and other resources that are available. Okay, so the presentation outlines, we'll look at recent conditions going back over the last month or so. Year-to-date precipitation, for example, 30-day temperature and precipitation, also drought conditions. Then we'll look at growing season progress, and I should have changed this to just the growing season because we're effectively finished with row crops here. We'll look at various other indicators, snow, fire, rivers, and lakes, and then impacts and notable events. And those are those anomalous, off-the-chart, bizarre weather events that we've had: tornadoes, very high dew points, record-setting heat for December. Then we'll look at the outlooks, La Niña implications, the short-term outlooks, and then our seasonal outlooks, winter into spring. On the right-hand side here is a picture looking downtown towards downtown Des Moines, and this is during the evening, and you can see the streets are sweating. We have had very warm air masses over cooler surfaces, and we've been getting puddles forming in which I've never seen before. We had to check radar yesterday morning to make sure it hadn't rained because we had puddles. It just shows you how anomalous weather events were yesterday. So first we'll look at recent conditions, November temperature and precipitation ranks, year-to-date temperature and precipitation ranks, and then other indicators such as departures from normal or climatology, soil moisture, stream flows, and then implications on drought. Well, so the first thing we have here is the November temperature ranks, and these are statewide average temperatures for the states. And the period of record here is 1895 to 2021, I should say. So the darker the reds here, the warmer the temperatures. Even the darkest red there, which we don't have on the map, would be the record warmest November on record. Now you can see across much of the western half of the region, we've had above average to much above average temperatures. If we look at our eastern friends in Kentucky, Indiana, Ohio, Illinois, near normal to slightly below average temperature-wise. Now, if we look at the year-to-date temperature ranks, basically across the United States, except the southern states, we've been above average to much above average. And this has been reflected recently in the last several months, especially with fall being generally warmer and drier than normal across much of our central region. Caveat there, we have had some wet months. October was the 10th wettest October on record for the state of Iowa, which really helped our drought conditions. Now, if we look at the precipitation ranks for November, what you see across the board are those brown colors, generally below average across much of the region, with near normal precipitation in North Dakota, Minnesota, and Montana. But we look at Illinois, 9th driest November on record going back 1895. So relatively dry conditions after a wetter October. If we look year-to-date precipitation ranks, there is a crossover point here from wet to dry, and basically southwest or southeast of Iowa, wetter than average conditions across much of the southern and Atlantic states. And then we move over Iowa into the upper Midwest over towards Montana, near normal to drier than average conditions. And then we look at Montana, fourth driest year on record through November of 2021. So very dry conditions. And this is reflected in the D3 and D4 drought conditions that are found in Montana, but also the recent wildfires that we've seen. And I'll go over those shortly. Now, if we look at the last 30 days, departure from normal temperature, wherever you see those warmer colors, which is basically across the entire central region, that's where we've been anywhere from 4 to 6 plus degrees above average. Now, this is over a 30-day period. So when you have very warm conditions, 6 to 10 degrees above average, that tells you that it's been an extremely warm last 30 days. And this is reflected in the extreme temperatures that we've had across the central region over the last several days, but even over the last 7 to 10 days. Now, if we look at the percent of normal precipitation, wherever you see those warmer or dark warm colors, dark red colors, that's where we've been really below average. Now, we are moving into the drier part of the year for much of the Midwest, so it doesn't take a lot to get below average. But when you see conditions at the 5th percentile, or 5% of normal precipitation, that tells you things have been very, very dry. Now, we will see a rebound from the squall line event that we had yesterday that moved through Nebraska and Iowa in the precipitation field, given there's a 1-day lag on this. But generally within that ellipse, very dry conditions. And then this looks like a station anomaly in North Dakota, given the broader scale dryness that we've seen. But overall, if we look at the central region, drier than average conditions, with only pockets of wetter than average conditions in Wisconsin, the UP, Michigan, and down into Indiana and Ohio, and even Kentucky. So another moisture indicator that we use is the 0 to 200 centimeter, or basically 80-inch subsoil moisture percentiles. If you think of a sponge, the 100th percentile is a soaked sponge, no room for additional capacity for soil moisture. Now, this is a NASA Sport remote sensed product. We have tended to be drier in some parts of the region, which is not reflective of soil moisture probes that we do, especially across northern part of Iowa. And then you see that bullseye of 5 percentile or below in southern Wisconsin. So overall, we are seeing drier soils, especially topsoils, given the dry conditions and warm conditions that we've seen. But we have seen a marked increase in the amount of subsoil moisture just over the last several months from where we were late summer, when drought conditions were more pervasive, especially across the Dakotas and into Minnesota. Now, I mentioned topsoil. This is the last reporting period for USDA NASS, National Agricultural Statistics Service. This is a percent of short to very short on the topsoil, and this is the November 28th report. Anywhere where you see those darker brown colors, that's where topsoil moisture is extremely lacking, very, very dry soils. Now, this is not telling the tale deep down into the profile as the previous slide shows, but what this is telling us is that we've had warmer and drier conditions, and it's reflective in these topsoil conditions. Now, using all those moisture indicators, plus an additional suite of tools that we use every week for drought monitoring, we see the current drought depiction, which is backdated to Tuesday of this week, December 14th. As a reminder, data cutoff is 7 a.m. on Tuesday. So anything that falls after that time period is reflected in the next map. Basically, what we see are the driest conditions for the central region in Montana, D3, extreme to exceptional drought conditions. Now, when we look at that D4 category, basically we would only see that once in 50 to 100 years. It's a very, very anomalous dryness through the system. Luckily, we haven't seen that a full bore across the central region. We have had pockets in North Dakota and in the upper part of Minnesota, but we have seen some improvement, and we have seen some degradation, and this is reflective in the 4-week class change. So wherever you see the cooler colors, the greens and the blues, that's where we've seen improvement, one category. And wherever you see the yellow or warmer colors, that's where we've seen 1 to 2 class degradation. Wherever you see green across that map is status quo, no change, nothing in the system that would improve or degrade. So basically across the central region, we've seen degradation across the southern tier of states, improvement from in the Dakotas over into parts of Montana, but overall status quo if we exclude Colorado, Kansas, and Missouri. Okay, so now that we've seen our moisture variables and temperature behavior, let's look at where we sit with soybean and our row crop harvest. So if we look at the left map, that's corn, the right map is soybeans, and these figures are courtesy of Brad Rippey at the USDA. These show us the progress that we've made across the states in harvested corn and beans. As you can see here, wherever you see those greener colors, that's where we're ahead of the average, the 5-year average. So we have seen a pretty good amount of harvest and completion of harvest across much of the states, both corn and soybeans. Now, if we look at the soybean side, the eastern part of the region has been wetter over the last several months, and that's reflected in the less change from the 5-year average. And I will note that we have continued to see harvest even into last week across Ohio and Michigan. If we look at sorghum progress on the left and sunflowers on the right, basically near the average or above average for Colorado and Kansas into the Nebraska and South Dakota. And then on the sunflower side, anywhere from 2% to 12% above average. So we are on the good side of the 5-year average in terms of sorghum and sunflowers. Now, winter wheat conditions, variable across the region, but where we are growing winter wheat, we have seen on the left-hand side here, the percent good to excellent versus last year, slightly below average in South Dakota, but all of the other states within the region, with the exception of Colorado, have seen an increase in good to excellent over last year. On the right-hand side here, this is the percent to good to excellent versus the previous week. So improvement basically across the board to near average on the 5-year average, our change from last week in South Dakota. And then we look at percent emerged in the center bottom plot there, about a 1% increase across the board for winter wheat emerged, behind average on from Illinois over to Ohio and up into Michigan, and then ahead of the average in Missouri, Kansas, and then into Nebraska and South Dakota. Okay, another interesting thing here we saw on social media, Minnesota and North Dakota sugar beets. I'll read the tweet here. Although we battled extreme weather conditions and a drought this year, we are so proud to share that we had a record-breaking harvest of 1.8 million tons of sugar beets. So even given the extreme weather events that we've had across the upper Midwest and the drought conditions that we've seen, sugar beets broke the record. So good for them. All right, now we'll move from agriculture into snow, fire, rivers, and lakes. And this will give us an idea of longer-term behavior that we've seen across the region. So the first thing of interest is modeled snow depth departure from normal. So we take the climatology of what we expect the snow depth to be for this time of year, and we subtract that from climatology. Wherever you see those yellow colors, that's where we're below average on snowpack. Wherever you see the blue colors, so basically a strip in South Dakota, up into North Dakota, and then over into the far western part of Montana, we've seen slightly above average snowpack. What it looks like, though, when we look at the snowpack in general, not too deep, and this is reflective in fire conditions that we've seen in Montana, but also below average snowpack availability, and hence this is a component of the warmer temperatures that we're getting. If you don't have an existing snowpack on the ground, you're not able to reflect a lot of that incoming solar radiation, and temperatures are able to rise. We have a lack of snowpack across the state of Iowa up into southern Minnesota, which actually had a pretty substantial snowstorm just a few weeks ago, and most of that snow is gone given the warm temperatures. If we look at the SNOWTEL current snow water equivalent, so if we took that snow and we melted it and we measured that snow water equivalent as percent of normal, we're anywhere from the high 70s into the low 60s, upper 50s. So we are seeing a below average snow water equivalent within that basin-wide percentage. Now, of course, this is early in the snowfall season, so we do have time to go, but these are relatively low compared to where we are at this time of year. I mentioned the warmer and drought conditions that we've seen in Montana. We've seen significant wildland fire potential for December. And most of the area in the red ellipse in Montana has large precipitation deficits going back several months back a year. And these are reflected in those D3 and D4 conditions. So we have soil moisture that's telling us something, we have snowpack that's telling us something, and they're converging on these drought conditions given precipitation deficits, and hence with warmer temperatures and dry fuel, we're able to get significant wildfires in Montana, and I'll go over those shortly. If we look at the Missouri River, the Missouri main stem reservoir status as of this morning, system storage is below 50 million acre feet and running below the drought year of 2012. Now it's basically 5 million acre feet off of the 1969 to 2020 long-term average. Gavin's Point Dam is currently releasing 12,000 cubic feet per second. And overall, this is the 10th lowest runoff year on record, with the period of record going back to 1898. So you can see the red line on the plot here on the right, below the average, but also below that 2012 status. So very dry conditions within the Missouri Basin. If we look at stream flows, this is the 28 average stream flow. You'll notice across the upper Midwest a lack of dots there. That's where we've started to see streams freeze and our river gauges are not reporting. But overall, if we look across the parts of the central region where we do have stream gauges reading, we are near normal to slightly elevated across parts of Iowa. And then we have some gauges in Missouri that are near normal to slightly below average. And then we get the blip over there in Indiana. Not sure if that's an anomaly, but we overall in the Eastern Corn Belt do see normal to slightly above normal stream flows. So what this is suggesting to us is that coupled with the wetter conditions that we saw in October, especially in the western part of the Corn Belt, eastern part of the Corn Belt, I should say, we're getting deep infiltration of subsoil moisture, and that's reflective in the stream flows rising. We're getting precipitation events and we're getting runoff from those precipitation events, and our tile lines are running, hence elevated or near normal stream flows from what we saw just in early fall and late summer. A Great Lakes water level, that I chose Lake Superior because basically all the Great Lakes are acting in unison here and running near their long-term averages. Now they have dropped from higher levels that we've seen over the last several years, and looking at forecast levels over the next 6 months, we should see those levels remain near the long-term average. Okay, impacts and notable events. Now we're getting into the, I don't want to say exciting, but into the interesting things that have been happening over the month of December. So state impacts, we've seen snowpack rapidly decrease in Colorado over the last several weeks until a recent event brought totals to near normal. Now, snowpack is still lacking in Colorado, so we would like to see increased snowfall, especially recreationally and for the economics out there of winter type recreation. Large wildfires across portions of Montana, and wild and unprecedented severe weather outbreaks across Missouri, Illinois, Arkansas, and Kentucky, and then yesterday across Iowa, Wisconsin, Minnesota, Kansas, and over into Colorado. This picture on the left-hand side here is from the destruction over parts of Mayfield, Kentucky, where we had, I believe, a preliminary estimated EF4 tornado that ripped through the town. Other state impacts, if we look at the image on the left here, a rare dust storm known as a haboob impacted Denver on December 5th. Greatly diminished sunlight, you've flying dust out there for a good period of time, along with anomalously high winds. And at that point, Denver had yet to see its first snowfall of the season. And in fact, it broke the record length of 233 consecutive days with no snow. And then we had a substantial dust storm associated with the low pressure system that moved through the upper Midwest with gusts over 100 miles per hour in parts of Colorado. We look in the middle here, we had a late season wildfire in central Montana, which incinerated much of the small farming town of Denton, and this was in early December. The fire was fueled by high winds and given that lack of snowpack, had unfettered access to dry vegetation. And this, with the exceptional drought conditions, really fueled very hot and intense fires, which were able to melt rail cars. It also destroyed more than 24 homes and 4 grain elevators. I'm sure you've seen those pictures and video on the news. And these grain elevators had been standing for more than a century. Finally, if we look on the right-hand side here, a heavy snow event across southern Minnesota on December 10th and 11th in Minnesota, and up to 21 inches fell across the southwest corner. I-35 was shut down over multiple times, and there were over 300 car wrecks. During the height of the storm, snowfall rates approached 2 inches per hour, and that's a pretty steep amount of snowfall to fall. The picture on the top there was taken, I believe, by Pete Boulay at the state climatology office, but that just shows you how that heavy wet snow just sits on everything. Station extremes. Now, this is not a very good list, given that a lot of records were broken yesterday, and we're still going through those preliminary numbers. But the state climatologist of North Dakota sent along the Hettinger, North Dakota, broke a daily high temperature record of 71 degrees on December 1st, which is also the state record for a December day. And that previous record was 70 degrees, and that was broken on December 20th, 1894 in Napoleon, North Dakota. Several stations in Iowa broke December's high record high of 74 degrees on December 15th, and this record had stood since December 6th, 1939, when it was set in Thurman, Iowa. We had stations across the state beat their records by 15 to 20 degrees. We had temperature anomalies across the central region, anywhere from 30 to 40 degrees above average on the 15th. And with those high dew points, many stations throughout the Midwest broke those daily high and low temperatures, but the dew point temperatures were really telling how much moisture was available out in that air mass. Moisture availability, along with anomalously high temperatures, produces instability in the atmosphere, and hence the event that we saw yesterday. So just a map here. This is the observed maximum temperature for December 15th. And wherever you see those maroon or dark red, that's where the highest temperature recorded for the date. Also, we have records in there, as I mentioned, daily records, but also monthly records that were broken across much of the central region. But it really shows you the heat and instability that was available for the system. Okay, now we'll look at severe weather. This is a picture that was taken by a Des Moines Register reporter who was near Atlantic, which is in the western part of Iowa. This tornado happened to hop right over his vehicle, and he was able to capture this screenshot. We did have a lot of semis tipped over across the region, given the non-convective high winds for the gradient event, and I'll explain what the gradient event was, but also a lot of thunderstorm gusts that did a lot of damage across agricultural parts of western and northern Iowa, along with Minnesota and into Wisconsin. First, we'll look at the December 10th event, and this was the severe weather outbreak that happened across Missouri, Illinois, Kentucky, Tennessee, and Arkansas. One of the most notable thing is the historic long track tornado that entered western Kentucky from Tennessee shortly before 9 p.m. This would be the tornado that would hit Mayfield. The path length estimate on this is 190 miles, and that's one of the longest long track supercells that we've seen. Now, the reason why this supercell was so devastating, it was a discrete supercell. It was able to form in its own environment. It didn't have any other storms to compete with. It was able to gobble up all this instability and stay on the ground for a long period, and we did see EF4 isolated pockets of possible EF5 damage within that path. More than 80 are feared dead, with many more unaccounted for. Unfortunately, when you get tornado outbreaks late in the year, these are typically very strong tornadoes after the sun goes down, and it's hard for observers to spot those tornadoes and get an accurate track on those, and hence the devastating loss of life. If we look on the bottom left here, that's from our friends at the Kentucky Mesonet showing the peak wind gusts. If you look down on the bottom left of that plot, you'll see the Mayfield station with a peak wind gust of 107 miles per hour. Definitely higher sustained winds and gusts that were recorded along that path. We also had a tornado outbreak across Missouri and Illinois. The worst of these tornadoes was an EF3 that set down west of St. Louis, Edwardsville, Illinois, where a large Amazon warehouse was literally split in two. So far, there have been 6 confirmed fatalities and several injuries from this damage to the Amazon warehouse. This event was the first in 4 years with a tornado-related death in Illinois, and as I have in this previous bullet point, up to 6 confirmed right now. Okay, secondarily, the 15th December event. This is the first moderate area put out by the Storm Prediction Center in Iowa, Minnesota, and Wisconsin during the month of December in SPC history. So this tells you how unstable the environment was. We had wind shear available, we had instability available, we had ample low-level moisture, and all the ingredients came together for a large-scale straight-line wind and tornadic event. We've seen widespread damage from severe thunderstorms with wind gusts exceeding 70 miles per hour, locally up to 80 to 90 miles per hour. We've also had multiple reports of 70 mile per hour winds with based on non-thunderstorm winds. So these are winds that are produced by the tight pressure gradient that the low pressure system was able to produce, given its proximity to a blocking high pressure system that was able to amp up our temperatures during the day, overnight on the 14th and into the 15th. At least 5 tornadoes have been reported in Iowa. Surveys are continuing. We had the first tornado in Minnesota history in December, and we've had one fatality with a blown over semi in eastern Iowa. But given the large scale nature of this outbreak, while one fatality is too much, it is good news that we were able to get the proper warnings out. This event was pretty well forecasted. Messaging was very specific on this, so we were very lucky across the state and across the region. This is a Weather Service slide that was produced for a briefing in which I participated in this morning. Prior to the 15th, only five confirmed tornadoes had happened across the state of Iowa in December. And as I mentioned, no reported tornadoes in Minnesota prior to this event. Dating back to 2004, 55 plus reports of significant wind gusts of 75 miles plus is the most ever for the lower 48 states, surpassing the August 10th derecho that put down devastating damage in Iowa and into Illinois, and that was at 53 reports. This was Iowa's warmest December on record in terms of the statewide temperature record. As I mentioned, previous record was Thurman. We have a 75-degree reading in Ottumwa, but we also have a 76-degree reading at one of our co-op stations. So again, this is still preliminary, but again, with the broad scale of the high wind warnings that we had from Colorado all the way up through Minnesota and Wisconsin, shows you how significant, and this will be a historical event that we had in December. And if you look on the lower right here, those are the storm reports overlaid on the moderate and enhanced risk that was issued by the Storm Prediction Center yesterday. So the modeling did a pretty good job on locating where the most intense of these thunderstorms plus the non-thunderstorm gusts were going to occur. Also associated with the system was an extremely critical fire outlook for the southern and central plains during that December 15th event. And this is the first for December in the Storm Prediction Center's history. We saw dangerous and life-threatening fires occur in Kansas, and I'll show you a plot after this. And these fires were spread easily given drier conditions, very high temperatures, and also extremely windy conditions. So the perfect ingredients for a fire outbreak. If we look at the storm summary for the central United States, it's broad scale. It's from basically eastern Colorado all the way up through Nebraska, Iowa, Wisconsin, Missouri. Didn't get out of it. So we just had an insanely difficult situation in which the pressure gradient was as such that it could produce these wind gusts that we would typically see in severe thunderstorms during spring or in summer. So if we just look at a sampling of these, there was a Lamar in Colorado had a 107 mile per hour gust. Mason City Airport had an 83 mile per hour gust in Iowa. And then anywhere from 85 miles per hour in Minnesota to 90 mile per hour in Texas. This gives you the extent of how large this system was, but also how fast this system moved. And an interesting thing, after the line had gone through Des Moines, there was a report of an acrid smell. And we had a lot of people across Iowa, but also in Nebraska and Kansas smelling this. And, after the line moved through, people were cognizant that perhaps, with these strong winds, we had power fires that were caused. Well, it happens that this stinger jet formed in Kansas, and what it does is it's drawing that dust in with it. So if you were to go outside this morning, as I did, and look at your car, it had a mixture of raindrops and dust, and this dust was from Kansas. It also happened to have some fires, larger scale fires in Kansas, and that extreme temperature gradient and those wind speeds transported that smoke all the way up into Iowa and into Wisconsin. So on the right-hand side here, city of Waukee, which is a suburb of Des Moines, actually sent out a advisory saying, no, this was not a localized smoke or fire event. This smoke was from several hundred miles away. So this, again, highlights how strong this system was. Okay, finally, we'll look at the climate outlooks. We'll look at La Nina implications, and then we'll look at our short-term forecasts all the way out to our seasonal forecasts getting out into March, April, May. Okay, so we're currently in a La Nina advisory. In October, the tropical Pacific and atmosphere both coupled and indicated a strengthening La Nina. So you can have the La Nina is the cold phase, so a cold sea surface temperature anomaly. And what it happens is it pushes convection or thunderstorm activity further west in the basin, and that impacts where the jet stream and storm path sets up over the United States. Now of note, we had a La Nina going into winter last year. We transitioned back into what's called ENSO neutral from late winter into spring. But when you see that behavior happening, we typically get a double dip La Nina. And that's where we are now. We're currently in a La Nina, looking weak to moderate right now. And it's looking like it's going to continue across the northern hemisphere through the winter time into 2022. And then we have a 95% chance during January through March and into the spring of 2022. Then we get some semblance of a signal where 60% chance of transitioning back to ENSO neutral later in the spring. On the left-hand side here is the Nino region in the tropical Pacific. Wherever you see those colder colors, that's where we have a negative sea surface temperature anomaly. So colder waters push warmer waters further west. That's where you have convection set up. Now, if we look at wintertime patterns during the 20th strongest La Nina events, across the board we have some variability. We've had years such as 1991 or 1999 in which we've had above average temperatures across the board. And then we have years such as 1984 to 1985 in the center of this plot in which we have colder than average temperatures. But when we look at analog years of weak to moderate La Ninas, we do see a basic configuration set up, and I'll show that in the next few slides. Precipitation is another beast when it comes to La Nina phase. There's very high variability when it comes to what happens precipitation-wise across much of the central region. Now, if we do look at the analog years with low to moderate La Nina phases, we do tend to see a bullseye of above average chances of wetter conditions in the Ohio Valley up through the Great Lakes, and then a secondary location in the Pacific Northwest. And then across the southern states, basically, we do trend drier than average, also warmer than average. So if we look to start us off at the 7-day summary or the summation of precipitation that we expect, if you watch the news every night or read the newspaper, this gives you the sum total of the precipitation that we're expecting across the United States. So basically, a pretty dry pattern set up. We do have a wetter storm track over southern Missouri through southern Illinois into Indiana, but basically dry conditions moving northwest. If we look at the 8 to 14-day outlooks, I will orient you here. On the left-hand side here is the temperature probabilities. The right-hand side is precipitation. Wherever you see those darker colors, those are higher probabilities darker colors of red, higher probabilities of warmer than average temperatures. Wherever you see those blues, higher probabilities of below average temperatures. So what we're seeing across the central region is a dipole activity. Very high probabilities of colder than average temperatures across the Canadian-United States border, Montana into North Dakota, and then those probabilities slightly leaning off and then getting into above average as we get into the southern part of the region. Coupled with this, we do see a wet signal across the upper Midwest through Wisconsin over into the western part of the central region. But when you see a probability this low in the driest part of the year, this is not telling you a lot. So we could have near normal behavior given that this is getting into the driest part of the year. And these plots are valid out through the end of December. Now, we did see a hint of, in that 8 to 14 day outlook, of colder than average temperatures, higher probabilities of that. Well, we're seeing this in the 2-week risk of hazardous temperatures, where we do see a high probability of much below normal temperatures in Montana, filtering down into the Dakotas, and then western part of Minnesota has a slight chance for this behavior. If we look at the January outlooks that were issued this morning, these are the initial outlooks, we're not getting a clear signal temperature-wise across much of the central region. We call this equal chance of above, below, or near average behavior with a slight tendency towards climatology, or what we should expect in January, at 34%. Now, what we are seeing on the precipitation side, again, is that classic La Niña configuration in which we see an elevated wetness probability in the Ohio Valley into the Great Lakes, and then over into the Pacific Northwest. On the flip side, generally below average probabilities for higher probabilities for below average precipitation across the southern states. The final January outlook will be issued on December 31st. If we look at the season of January, February, March, temperature on the left, precipitation on the right, similar behavior on that precipitation front, where we do have an elevated bullseye right where we would expect for a La Niña winter, with those probabilities shifting slightly west towards the state of Iowa and into Wisconsin and extreme southeast Minnesota. Temperature side, we do see those higher probabilities of warmer temperatures slightly moving further northwest, with the classic signature for below average temperatures in the Pacific Northwest. If we get out further than that, March, April, May, getting into the planting and growing season, that bullseye of above average precipitation probabilities does hang out in the Ohio Valley up into the Great Lakes. And then we do see much of the southern part of the region with slightly elevated probabilities of warmer temperatures. Now, these are 2.5-month lead outlooks, so we will see future iterations of these. And part of this will depend on the strength of La Niña and how those will impact the seasonal outlooks moving forward. The seasonal drought outlook, as published by the Climate Prediction Center, does show drought persisting across the western part of the Dakotas and northern parts of Minnesota, and then improvement across Montana, and then on those smaller D1 regions within Iowa over into Wisconsin and Illinois. So generally, if we look at the outlook models and those longer term forecast models and climatological models, we are showing some semblance of a wetter pattern that will impact and improve drought across much of the central part of the region. Okay, so the outlook summaries, short-term outlooks are showing colder and wetter north to warmer and drier south. That classic La Niña signal is showing still in the updated monthly and seasonal outlooks, with a high probability of the strength of the La Niña phase being weak to moderate. We shouldn't see a lot or any major changes in the maps moving forward, just given the knowledge that we have for analog years of the La Niña phase. I did mention that analog years do show high variability in terms of temperature and precipitation when we compare those to the patterns that we would see in the warm phase or the El Nino phase. Some of the biggest signals that we see, again, are on those classic parts of analog La Nina years in the Ohio Valley, the Great Lakes, and Pacific Northwest. And those are wet signals. Further information, past and today's recorded webinar, and then all of those different sources of plots and figures that I showed, Climate Prediction Center, the U.S. Drought Portal, Drought Mitigation Center, our state climatologist website, and our regional climate centers. Finally, I want to thank you all for being on during this very tumultuous December. We will take questions, and here are our contact information if you do have questions that we can't get to. And with that,
thank you. Yeah. Hey, great, Justin. Thank you so much for your time and effort. I know you had a few other, and you still have a few other responsibilities to attend to. Could you go back up to your temperature and precipitation analog years for La Nina, please? While you're doing that, I just want to reiterate how unusual. One thing we don't do on this call very often is dwell on severe weather unless it is climatologically out of place. We do mention it from time to time. If these scenarios were happening, I suppose, in April and May, we would say, yeah, it's really bad, and these things happened, but we probably would say these are all within the parameters of at least what we're used to. So I'll just have to say we're all, as a climatologist and everybody involved actually in putting these things together, we're all surprised. Okay, this is all surprising to us. Certain ingredients all have to come together to make it happen. So it's just very hard for it to do that on and that's why first time we've ever seen tornadoes, recorded tornadoes in Minnesota, and record high, all-time record high temperatures for the month of December. The request was from Benjamin Diamond to go back and look at these. I think what you were showing or talking about when it comes to La Nina is the variability of the outcome. No matter if it's a strong, moderate, or even a weak La Nina. This is temperature, and you can see that there's, depending upon the years, it really can vary from pretty cold to pretty warm, but the preponderance is what you saw in the forecast for that cool air to be to the north and a warmer air to the south. Now, if you go to precipitation, it's much harder to see, and actually precipitation is more variable. So, but generally, again, northwest U.S. into Montana, sometimes into the northern Rockies as well, even northern Colorado, tend to be a little wet, and places south of there, at least in the west, are dry. And when you get further east, again, the wetter portions tend to be Ohio Basin and Great Lakes, at least some portion of the Great Lakes, a number of those years. In between the Great Lakes and the mountains, well, you see a lot of white there. So I'm not predicting average, and I don't think anybody is, but I don't know if Dennis or Justin want to say any more about precipitation in La Nina.
The interesting thing is, and I didn't include these plots, but if you look at the strength of La Nina versus snowpack, in those years in which the La Nina phase has been weak, we actually see above average snowpack across the upper Midwest. And we saw that last year. Iowa averaged 10 inches over the climatological normal, and that was a weak La Nina last year. If we look at all La Ninas together, we're about average across much of Iowa into Minnesota. So we do see these climatological flip of the coins, but El Nino and La Nina are only one atmospheric pattern that we are dealing with. We have other oscillations in the Pacific that can impact the jet stream. We have shorter range things like the Arctic oscillation that produce those cold air outbreaks across the upper Midwest. So all these little cogs go into the entirety of the outlooks that are produced.
Yeah, some people would say that, La Nina or El Nino might help predict about 10 to 20% of the actual outcome. And again, that varies on the year. And it really does depend, as Justin just said, on a lot of the other chaos in the system behaving one way or the other. And we don't talk too much about the AO Atlantic Oscillation or the North Atlantic Oscillation or anything like that, because those are shorter term, often week to week. Well, this is, let me say, we can only predict those out a couple weeks very well. There are some indications that it's going to go negative, which could mean cooler temperatures spilling in, probably will mean cooler temperatures spilling into the eastern part of the U.S. Over the next couple of weeks, at least back to normal. So that's the other thing we have to try to remember here is the average high here in Kansas City is 42. And the next 7 days, we have one day that is actually below 42 for a high. So it's going to seem like cold. It's going to seem cold, and it won't be. So anyway, let me go back to the other question, Dennis. This is one you answered on the fly. Winter. There was some interest in winter wheat damage, and I'll just say from any of the all of the conditions that we've had in the fall, including some of these very high wind events over the last few weeks. Anything we can say about damage to winter wheat that we know of yet?
Yeah, Justin, can you go back to the winter wheat page that you had where you had the conditions? This is a couple weeks old because USDA NASS stops reporting on crop conditions during the winter. Kansas and kind of the Central Plains winter wheat condition was actually fairly good as of the last report. So we're less concerned about the overall issue. Certainly the winds that were there yesterday, may have desiccated, dried out some of the crop, even though it's not really actively growing at this point. There may have been some cutting or sawing of some of the plants because of the amount of blowing dust that we had. The problem we don't have right now, since it's not actively growing, we don't know how much damage overall there was, and we haven't been able to collect any local reports. So there's probably some right now. I don't think I would react to it too crazily. Colorado and some maybe Oklahoma, Kansas are the places that were probably most harmed by this, maybe part of Nebraska. Most of the rest of the area probably should not have been affected too much by it.
Yeah, the interesting thing about the level of wind that we had and the dust storms, the fact that we had dust storms, also, and Dennis, maybe you can just comment on this, is it actually moves the soil around where it's loose or where it's been dry, and it can cover up crops and such. I don't know about the recovery from that or not, but those are other issues.
Yeah, there was a huge amount of blowing soil yesterday because dry conditions and strong winds are not a good combination. I haven't seen any deposition reports. Certainly, we got some of Kansas's soil up here in Iowa. I would prefer they have kept it. It's better for them down there than adding to us, but that was the way it was.
Okay, the next question is along the lines of severe weather and the recent tornadic storms, and are they a product of a warming climate due to human-produced greenhouse gases? And the answer to that is probably maybe. And I'll say maybe. What I would say is that I think the likelihood of tornadoes in December and January and other off-season severe weather is enhanced or will be enhanced, and will be enhanced in the future. There have been some preliminary studies talking about, and I don't know how well-founded these are, so I won't go too far out on the limb here, but the center of, Tornado Alley moving further east out of the Great Plains and such, and then of course simply the observation of severe weather in other parts of the year can lead one to that conclusion to some degree. Anything else from you two guys?
Sure, and I concur with everything you say. We have had above average Gulf temperatures, Gulf of Mexico, so that moisture gate has been enhanced with transport of lots more water vapor than we would expect this time of year. We had dew points in the 50s and 60s yesterday. That tells you that we had a rich moisture source, and that is a reflection of the increased temperature that we're seeing trend-wise in wintertime.
Yep. Yep, and those conditions are very hard to put together, again, in December and January, certainly in Minnesota, but even in Iowa and Nebraska. And further south you go, the easier it is to put all the combination of those variables together to create severe weather, but certainly not this far north.
Yeah, and definitely not the configuration that we saw yesterday with the non-severe thunderstorm winds that were produced by that system. That you don't. This is something that we don't have an analog for right now.
It is common to have what we call a Colorado low, which was a low pressure system coming out of Colorado or northern New Mexico, whatever. Those things tend to drop in pressure, increase winds. It's not unusual to have high winds, maybe not 50, 60, 70 mile an hour winds this far away. They were over 100, I think, near the Front Range. Anyway, all that's not that unusual, I guess I'd say. But having the available moisture, which really means energy, from the Gulf, is a bit, and I think it was prolonged. So, okay, let's move on. Okay, Dennis, I think you like to talk about these things, so I'm going to see if you do today. In general, is the second year of a double dip La Nina. So that means two La Nina, if you will, years in a row. And is the double dip La Nina, and I think he means in the second year, more or less stronger than the initial year? Are there any trends with double dip La Ninas?
I don't think there's any trends per se. Some of the national folks have talked about, I think typically the second year is not as strong as the first, though I think this year will probably be somewhat equivalent to last year in strength. So I don't know that tells us anything more specifically, though some of those national folks did talk about patterns maybe lock in a little bit better in the second year, atmospheric patterns. And definitely, I would say so far it has done that. Warm in the south, colder to the north, and really not shifting too much. We've just not had much of that cold air make it much farther than the far northern plains. And it doesn't look like it's going to do too much of that more in the near-term outlooks.
The other thing I will say about La Nina, not necessarily first or second year, is that there has been a tendency or rule of thumb in that they get started in terms of the cold and the precipitation. So tends to get going later in the winter. So we'll see halfway through January whether we flip, if you will, to real winter or something like that, and that carries through February, which has been a bit of a trend, especially with La Nina's behavior. The unusual part about this La Nina so far, even though it has been generally a stereotypical La Nina signature and such, is that the warmth has extended much further north than several times in the past. I guess is probably the best way to say that.
And I guess the one oddity we've had is there's been plenty of cold north. Alaska, parts of Canada have been, there's plenty of cold there, but colder than average. And typically we would expect that to break off and move south, and it really hasn't done too much of that.
Yeah, it tends to shift off to the east rather than to the south. apparently. With regard to, let's see, well, this comes from our colleague Brad. With regard to statewide winter wheat conditions, many states will provide a monthly update on January 4th. So we'll have that, Benjamin, for the January presentation. And then a kind of a final question is, have there been triple dip La Niñas? And I do believe there have, but I don't know anything. Can't think about the last one. Anybody?
I'll see if I can find it quick.
Okay.
And thanks, Brad, for the comment.
Yep. And while you're doing that, Brad to the rescue. 98 to 2001 was a triple dip La Nina. And if you ask me what kind of weather we had during that period, I would say I don't remember. I think we had pretty mild winters through that period.
We got the composites. We got the composites, and two of those winters were notably very warm winters.
Yeah. We do have the composite. That's right. Beginning of the Great Western Drought also. Oh, okay. Interesting. The other thing that hasn't been mentioned is that where we measure La Nina and El Nino in the Pacific, equatorial Pacific along the, it's been very stereotypical La Nina behavior, if you will. So everything at the atmosphere and the ocean are lining up perfectly, just as one would guess, I guess you'd say, with a La Nina. So from a predictability point of view, that's a good thing. You like to see everything line up so that you have better predictions. What does that mean for us is a little bit of a shaky story because, again, it depends on the other parts of the chaotic system that interplay with each other, like the AO and various teleconnections. Anything anybody wants to mention real quick before we get off here, and in terms of sort of, I don't want to say early, I don't want to be too sensational here, but early warning in terms of fire season or drought continuing, those seem to be, I'm not going to say more severe weather because I'm not going to predict that, but certainly wildfires and having these warmer than normal conditions and not having snow cover have led to another sort of unseasonalness, if you will, or anomalous wildfire season in terms of potential. I don't think we're actually seeing that many more, but the potential is there. Any comments on that or anything else?
Potential's there, but I don't think the predictability is there right now.
Right. I guess the other thing we heard from one of the state climatologists is that lakes aren't freezing over as early as they should. We had a late freeze year this year anyway, in terms of killing vegetation, but also lakes, and certainly the Great Lakes, are warmer than normal as well. So we can mention that, I suppose. Yeah, fuel load plays a big part in the fire, right? Thank you, Brian. And we did have that terrible smell in Kansas City as well. It smelled like fire, but it smelled like the fire was across the road, and it also smelled like they were burning something other than wood. and I was a little worried actually, and then I heard on the news that North Central Kansas had a big fire going, and don't know what became of that. So yeah, Lincoln had the smell as well, all the way to Iowa and beyond. Okay, I think we're going to wrap it up there. We're a little after the hour. I appreciate everybody staying on here. We'll do this again with Jeff Andreessen and BJ Bawley from Michigan, actually, next time, giving us a little more of an Eastern Midwest perspective and probably a lot about the Great Lakes. So stay tuned, and we'll see you next month. Happy holidays. And thanks, Dennis, and thank you very much, Justin.
Thank you.